Good evening, everybody. Welcome to Chapman University, and thank you for being here tonight. It's spectacular to see such a crowd for this event. Let me begin by thanking the three deans who have coordinated this event. Menas and Patrick and Bob, thank you for coming together and across the different colleges put together an event of this caliber. I would like to begin by giving a little bit of the background rules for how we're going to do it and some rules for you as well. Rule number one, if you could please turn off your cell phones. I want to see all the cell phones come out and being turned off.
Especially you.
Especially on the panel. Especially on the panel.
I've just got on vibrate so I can do a little texting.
Also, there should be ushers going up and down the stairs during the event. If you have questions, you should write them down, pass them along the aisle to the usher. They will bring them to me, and then at the end of the event, we will try to answer as many questions as possible. I also like to mention that if you'd like to share further thoughts or responses to the conversation of tonight, we have cameras that stand by at the exit of the theater, and you can do their short interviews for an online continuation of this dialogue. I think the topics that we're going to be discussed tonight are exciting, controversial, and so I ask all of you to respect the position of the panelists. They may be different, they may be sometimes objectionable to some of us, and so it's important that we allow the flourishing of the conversation, which I think is the most important thing in an intellectual environment. As for us, the way we're going to run this, we're going to have every panelist will make a 5-minute statement. We will begin from to the extreme left there with Jim Walsh, and we're going to go around. I will introduce the speakers one at a time. I will give only a very brief introduction because you all have a full description of the speakers in your booklet. At the end of the first round, we're going to go back and we're going to go a second round of 5 minutes. I have a watch here, which I will use to castigate those who violate the rules. And of course, Deepak Kafatos will not speak because he already spoke for his 5 minutes. Oops. And then at the end, I will have questions and I will moderate the Q&A phase. And I will try to make sure that although the questions are for the same person, we get some degree of variety in the kind of question that people are asking. 2 words about the topic. What are we going to talk about tonight? This morning, one of my students called me and said, what do you mean the nature of reality? What is there to talk about the nature of reality? Well, the first question is whether reality exists. And there are, as silly as the question may look like, there are several possible answers to this question. You may have an idealist philosophy that says, well, reality really doesn't exist. There is no such thing as reality. Everything is illusion, everything is appearances, and the only thing you have is what your consciousness creates, but there is no reality besides that. On the other hand, you have the hardcore scientist position. Of course there is a reality, and that's what science is designed to discover. We've been doing this for 3,000 years, and that's what we keep doing. And then there are a variety of nuanced positions. I think that tonight what you'll hear is some of this variety. For example, my position would be that, yeah, there is a reality, and science is a fundamental tool to discover such reality, but there may be aspects of reality that may be unknowable. We may get very close to the Big Bang, for example, and we perfect our understanding, our theoretical understanding, we perfect our machinery so that we can smash particles and recreate what happened very shortly after the Big Bang, but we may not be able to actually get to the Big Bang, just like we can get very close to the absolute zero and not being able to get there. So as you see, the question is actually much deeper than it appears. There are a variety of positions, and what I hope that we're going to have tonight is really an exposition of this position and some degree of debate about them. And now let me introduce our first speaker. As I said, is Jim Walsh, to my left. Jim is the co-founder and chairman of the Human Energy System Alliance Institute, which is a research and development company devoted to unlocking the potential of the human energy system. He's also the chairman of the Mind Matter Research Foundation. It's a non-profit foundation that is interested in issues of consciousness. Serves on the board for the Center for Investigating Healthy Minds at the University of Wisconsin-Madison Medical School. So, ladies and gentlemen, Jim Walsh.
Thank you. When Menas first asked me to come and attend this, I wondered why, because I'm the generalist here amongst all these specialists. And I realized that it would probably be informative for the students to see how a generalist goes about solving this problem. So the way I looked at this was we had two questions here. One was, is there an ultimate reality? And second, can we measure it? And for me, science is a useful discipline to measure the patterns of our world, make sense from it, and ultimately harness them into something useful. Whereas reality, to me anyway, is our perception of what is knowable. So given those two definitions for me, I thought we had two choices. And by the way, excuse me for using the notes, but my daughter told me I had to make notes. Otherwise, I'd run much longer than 5 minutes. So, but the ultimate reality is really, we really have two choices. One is we can say the ultimate reality, as Danielle just said, is what we perceive. And the limits of our perception defines the limit of reality. Or we can take the position that the ultimate reality is ultimately unknowable. And unknowable in the sense that it's beyond the realm of our consciousness. That the avatars who have actually gone to this place say that it's beyond words, that it can't be explained or understood except in the context of actually having that experience. That it's the ultimate reality, it's universal, it's eternal, and it's the point of transcendence of consciousness. So if we took that position, I wouldn't have anything more to say because I've never been there, I'm not an avatar, I'd only be speculating. So I kind of want to take position number one, which is in line with what we're doing at our research institute, which is taking a look at this as an evolving model of consciousness. And let me give you an example of what I mean by evolving model. Starting in about the 1600s to the 1900s, we had a classic period of science in that Newton, in his study of matter, and then the laws that govern the motion of matter, gave mankind a very good foundation for reality. Matter and energy were the foundation of reality. Everything else is built off of that. The sciences that came out of that, chemistry, for instance, which is a study how all that matter comes together in particles, how biology, how those particles come together to form a living system. Then neurology, how those living systems form a nervous system, and ultimately the experience of the mind. In a system like that, the mind actually is just simply matter, and feelings and thoughts come out of the complexity of that mind. It was a very solid platform. Great advances in mankind came out of it. And it was very pleasing to the church at the time, too, because the church at the time was very concerned about this investigation. And they often say Descartes, for instance, in the 1600s, had negotiated a truce with the church, saying that science could investigate matter as long as it was being able to be touched with all the senses, seen, measured, that was fine. But don't go into the realm of spirit or consciousness. And as Henry will tell you and some of the other people, that started the change in the early 1900s, where quantum physics gave us an entirely new paradigm of what reality was. All of a sudden, matter was just another level of reality, no longer the foundation. And underneath it was a field of potential. And that potential seems to be linked directly to this idea of consciousness. So, you can see now we have this evolving model of reality, and science changes with that model of reality. It seems that we could say that when our paradigms change, we change. And science is the means by which we go from mythic imagination to something that's usable, repeatable, and productive in our lives. So now we're starting to see right now sort of a shift happening again in science, where there's this emerging sense of consciousness as an essence of reality. So, as we follow this model of evolution of reality, we get back to the ultimate question. Is there an ultimate reality? And I love what Danielle had to say, is that as we evolve closer and closer and closer to perhaps the ultimate reality, it's a process. It's a process of being human. At my research institute right now, we've put an alliance together of universities, researchers, private institutions studying this idea of consciousness, trying to discover the pathways, the techniques that can harness this in useful ways for human beings. And the whole point to this, at least for us, is a question of, does the mind or consciousness have a place in the physical world? And if it does, everything changes, including consensus reality. Is it the ultimate reality? Well, given that history, probably not. It's probably one more step along the way. But what it does point out is that science is a faithful companion to our shifting paradigms, that it provides us something very useful along the way until we get to that spot of enlightenment, to that place where words and methods are no longer important, they simply are. So that's sort of as a generalist, that's how I look at this question, is that it's a process, and one that is very actively evolving as we speak.
Let me move to the second speaker. Our second speaker is Henry Stapp. Henry is an old friend of Chapman University, a frequent visitor here. He's a professor of physics at Lawrence National Laboratory up in Berkeley. He's well known for the development of a theoretical framework for the analysis of the scattering of polarized protons, and for his development of a relativistic framework for axiomatic S-matrix theory. More recently, his studies on the quantum measurement problem have led him to a rational understanding of the effects of our conscious thoughts upon the physical processes that occur in our brain. Henry?
Thank you. So we have two questions here that we've been asked. One is there an ultimate reality? And I must confess I do not know whether there's an ultimate reality and exactly even what that means. But I would say that given that we don't know, I think it's worthwhile trying to find it, at least not giving up saying it's impossible. So I would say let's try to find it if there is one. And so the second question is, I can answer in more detail. It says, if there is one, does science play a role in accommodating or accounting for it? And now, as a quantum physicist, the answer is fixed by orthodox quantum theory. And the answer is no, because the orthodox philosophy of quantum theory says that what science is about, and in particular, once we come to quantum theory, we realize that this makes great good sense. What science is about is relationships between experiences. That science is based on empirical phenomena, empirical data, and empirical data means things that are experienced by people. Science is a human endeavor, which we, human beings, create for ourselves in order to be able to predict, for example, what's going to happen if we do something. And so the official answer given by quantum theory is no. Science is not about, and it's not designed to search for the ultimate reality. Science is this useful human endeavor which is based upon empirical evidence. And and empirical evidence, of course, means things that we human beings experience. So you have to bring human experience into the picture, because that's what science is about. It's about relationships between human experiences. That's the official doctrine, the official philosophy of quantum theory. And I was just congratulating my colleague here on his recent book. He said it very clearly, much better than I've said it in a number of books, that you can't get the people, you cannot remove people from the scheme of things, because people are the things that are having the experiences. And if it's about empirical data, then you've got to have the people in their brains, because our brains are very closely connected to what our experiences are. So the bottom line, the official line in quantum mechanics is no. It's not about ultimate reality at all. It's about human experiences. And so now, why did quantum theory and quantum theorists move to this position? As you've just heard from Professor Walsh, we had a very wonderful theory that seemed to be a theory of reality itself. These particles moving around and bouncing around, and the theory that we had up until around 1900 was seen to be a theory of reality itself, a very satisfying idea that we were able to comprehend actually the ultimate reality in a pretty simple form, in fact. So to introduce the problem, I'm going to tell you about what Niels Bohr said in relation to what was going on at the Solvay conference of 1926. That was the conference where quantum theory was more or less invented and put on the table for display. He says that during the conference, a discussion arose between Heisenberg and Dirac, two of the principal founders of quantum mechanics. And the issue was, in this quantum mechanical world where you only have statistical predictions, what do we say about how the actual situation comes about? And on the one hand, Heisenberg said, we have to do with choices on the part of the observers. And Dirac said, what we're dealing with here is choices on the part of nature. Now, it turns out that those, in the way quantum theory is finally understood, both were absolutely correct here. The structure of quantum theory basically has three levels. It has a level which you call the physical level, and this is the level that is a direct mathematical generalization of classical mechanics. It's all about things that properties that are assigned to space-time points and how they evolve according to certain mathematical laws. But the problem is that if you just look at that level alone, that the world seems to evolve into this huge smear of possible worlds of the kind that we experience. So how do you get from this huge smear that the equations are giving you to the things that we human beings experience? And the way it finally worked out is that you need both of these ideas that I just mentioned. And John Wheeler, a famous physicist who was also involved with the creation, drew the analogy to the game of 20 questions. He said that the way the universe evolves according to quantum mechanics is like the game of 20 questions. And the questions get answered by the observers. The observers have to pose some question. They probe, they ask a question, is nature such and such? Is this property of nature something that can be experienced? Because if the question and the answer is to make sense to him, then the question is got to be answered in a way that he can experience the answer and distinguish yes from no. So the first phase of getting beyond this smear is for an observer to ask a question of nature. Does nature have this such and such a property? Something I can experience the answer yes or no. And then the next phase is, in the words of Dirac, nature makes the choice. And so now, if you look at quantum mechanics, these two parts have very different entries into the structure of the theory. The question asked by the observer, in ways that I won't go into, but in very well-defined ways, is a local process. It has to do with where the human being that's making the question, or the observer that's making the question, is located. On the other hand, the choice on the part of nature, which is answering the question, yes or no, is not like this. It has a global reach in the sense that somehow the answer that nature gives to some questions posed over here depends on nature's knowing, being able to know what some question asked far away at the same instant of time, in some sense, is. So you have this local, okay, so you have the local part and you have nature's part, and nature has this global aspect. So let's not talk about God, but if you talk about nature, then there is something in quantum mechanics that has something that goes beyond. It looks like maybe you're reaching something, a deeper level of understanding of what's going on by virtue of the fact that nature, this sort of nature has to become involved in the process according to the rules of orthodox quantum theory. Thank you.
I'm using a relativistic watch, which means that time dilates a little bit, because I hate to interrupt in the middle of a very good argument. Our third speaker is Leonard Mlodinow. He's a professor of physics at Caltech, author of course, numerous publications in the field of physics, but also 5 major books that have been very successful in the popular press. In particular, Euclid's Window, The Story of Geometry, From Parallel Lines to Hyperspace, Feynman's Rainbow, Search for Beauty in Physics and Life, A Briefer History of Time, co-authored with Stephen Hawking, The Drunkard Walk, Story of the Randomness and its Role in Our Lives, and then the very recent Grand Design, also co-authored with Stephen Hawking. Leonard.
So I, first of all, agree with a lot of what Henry said. So thanks for helping me along. So I'll try and condense the time. But I think first we should answer the second question. So the second question is how can we know about reality? And I don't think we can. And again, I think the reasons are somewhat obvious. The reasons I'm going to give, and they've been stated through history, that we have our senses, we filter everything through our senses. I think today we're much more aware that we also have a brain that is very important in what we think and what we experience of reality. So, with modern neuroscience, learning a lot about how we think, we realize more and more that our peculiarities or specific aspects of our brain shapes what we perceive on the outside in a very deep sense. So, when you see a table or a chair, your idea of that concept, the shape, not just the shape, the experience of the color, but all that isn't necessarily a property of the molecules as much as the molecules and all the data that's coming in, plus the way your brain thinks about things. So, as a physicist, as we try and look deeper, and Henry said that it's about experiences or observations. It's not really about reality. What we're trying to explain, we're trying to make predictions about the future, and we come up with mathematical theories. And for physicists, and in modern times, since we write books, for a lot of people who aren't physicists, the theories of physics tend to define what we think of as reality. Whether it's the model of the atom with the electrons swirling around, or the cloud of the electrons around the atom, or however you think about reality on a deeper level than just tables and chairs, comes from the theories of physics. But we have to understand that aliens on another planet with brains that function differently, or computers that are eventually coming up with theories of reality, could have ideas that are totally different from the ideas that we have. They would have to have the same. They would all agree on the results of the predictions, but the concepts that they use, be it an atom or forces, could be quite different to get them to the same place at the end. And you can even see this if you look at different theories of physics that are formulated today. That either say general relativity, Einstein's theory of gravity versus Newton's theory of gravity, and the way you look at quantum theory, they all have different ways of looking at things. But in experiments where they can all be applied in some way, they will all agree. So in that sense, but based on the way our mind works and the way our senses work, I'd say that we can't really know anything about any external objective reality. All we can do is what we can as human beings. Now, added to that are some of the things that Henry said, that our current theories of physics even call into question whether certain properties that we expect things to have, such as position and velocity, even exist. But I won't even go into that. But so all that said, let's go to question 1, which is there an external reality? But now that I've answered question 2, my answer is, who knows? I mean, we don't know. So that's it for me. Michael, take it from there.
So Michael Shermer, he's the executive director and founding publisher of Skeptic magazine. I think you received some copies as you walked in. He's also a monthly columnist for Scientific American and a adjunct professor at Claremont Graduate University, and hopefully at Chapman in the near future. His latest book is The Mind of the Market, about evolutionary economics. He also wrote Why Darwin Matters, Evolution and the Case Against Intelligent Design, and The Science of Good and Evil, and Why People Believe Weird Things. And his next book is going to be The Believing Brain. Mike.
Thank you. I will try to stick to a classical clock instead of a relativistic clock. So, is there an ultimate reality? Just out of curiosity, how many of you here in the audience think the answer is no, there is not an ultimate reality? If I could just see a show of hands. Okay, great, because after the event tonight, we're going to run an experiment, because this, I claim, is a testable hypothesis. We're going to go to the roof. We have cameras to record the experiment. We have data recorders to record this. And we're going to push you off one by one. And if you truly believe there's no ultimate reality, your non-existing atoms will pass mysteriously through the non-existing atoms of the ground, and you will not be hurt. End of story. So
I checked, they're calling me from risk management.
Risk management, yes.
They approved the experiment, so we won't be able to do that, sorry.
How's your insurance policy? I've been trying to do firewalks at institutions. They don't want to do that either. Anyway, so okay, so I'm a materialist, a monist. I'm not a dualist. I think humans are by nature dualists, that we think that there's an extra substance, a soul, a spirit, an agent, a hidden force, some kind of energy, a god, a gods, whatever. But that's a product of our brains misperceiving the world and infusing into it these hidden, invisible agents that we think are there that aren't really there. And you know I'm right because I'm a published skeptic anyway. So if you get a brain injury, if you get a stroke, particularly dramatically Alzheimer's or senility or dementia, as the neurons die one by one, so does your mind. There is no mind. The mind is just one of these fuzzy words that gets thrown about, that if we try to operationally define it carefully, we find we're just describing what the brain does. So mind is just a word to describe what the brain does. The soul is just a word, a fuzzy word, to describe our pattern of information, our memories, and our essence and our being, which dies when we die, and so forth. It's no more mysterious, by the way, where you go after you die than where you were before you were born. Why does nobody get all fussed up about, well, where was I before I was born?
I think Deepak does.
Well, actually, that's right. He does. You're right. Anyway, so...
I've had this argument with him in previous lifetimes.
I've won those, too. Anyway, I think as the brain dies cell by cell, so does your mind, your essence, your being, your soul. And you all know that. That's absolutely right. So if you're right, Deepak, that somehow the mind exists somewhere else, where did Aunt Millie's mind go when her brain died? Or whatever.
Or before.
Is it out there in some substrate, some quantum computer in some other alien universe? I mean, this just gets to be just pure fantasy. Now, I think there's much to be said about this quantum mechanics and the observer. I guess what bothers me, and when I say Deepak, I mean Team Deepak, anybody that's... What bothers me about it is two things that bother me about it. First is it's putting us back in the center of the universe. It's like Copernicus toppled us off the pedestal, and then Darwin toppled us off the pedestal, and then Freud, and then Einstein, and so on. And now here it is. We want to pull us back in. We are the center of the whole thing. In quantum mechanics, you have to have an observer. And why is the observer always us? Of course, it doesn't have to be us. It's any observation. It's the machine, the camera. It doesn't have to be us. But that's always what everybody's talking about. I am back in the center of the universe. I'm the most important thing. There's no reality without me. How convenient. Right? It just feels so good. I'm put right back in there. So let's run a thought experiment. Humans went extinct 150,000 years ago, and Neanderthals now run the show. Does reality still exist with Neanderthals as the observers? Or wipe out all the hominids, and it's just a bunch of dinosaurs running around, wipe out the mammals, whatever. Still does reality exist? Did they count as observers, right? So, and this idea that with the observer, like something like reality doesn't exist without the observer, therefore the moon doesn't exist without an observer. If you don't see it, it isn't really there. Well, to quote Bill O'Reilly, tides come in, tides go out. Never a miscommunication. Therefore, there's a God. Right. So the tides work because of the moon. It doesn't matter whether they're observed or not. They happen anyway, and they will without us. Finally, I think what's really going on here is quantum mechanics is spooky and weird, and consciousness is spooky and weird. So what? I mean, that doesn't mean they're connected. Charlie Sheen is spooky and weird, but you don't need quantum physics to explain the tiger blood. It's just brain chemistry.
Are you sure?
Thank you.
Then CNN was wrong, I guess.
Thank you, Michael. He certainly raised the temperature in the room, which is good. Our next speaker, she will be enough, is Deepak Chopra. He's an internationally renowned best-selling author of more than 50 books on spirituality and well-being. He's the founder of the Chopra Foundation, senior scientist with the Gallup Organization, chairman and co-founder of the Chopra Center for Well-being. Dr. Chopra is a fellow of the American College of Physicians, a member of the American Association of Clinical Endocrinologists, and an adjunct professor of executive program at the Kellogg School of Management at Northwestern. Deepak.
So, I'm going to be a little more affirmative and less ambiguous because I'm not an academic and I can risk my reputation. He's already called me Dr. Woo-Woo in many occasions. And he's already spoken of my language as quantum flapdoodle. So, yeah, I'm on the fringe and I don't mind being. But when I see him saying I'm a professional skeptic, and he wears a label on his lapel, by the way, which says skeptic, my first response is, I don't believe you. I think there's a deeper question than being asked right now than what is ultimate reality. What he's speaking about is perceptual reality, okay? Which is a very legitimate way of looking at things. But there's no question, and there's a neuroscientist here in our audience, and I think he'll agree, that what we experience as reality is actually an activity of the brain. And the brain in different species is quite different. For example, a honeybee's eye cells don't respond to ultraviolet, not to the usual wavelengths of light that you and I see. What does a honeybee see when it looks at a flower? A bat experiences the world as ultrasound. What's that experience like? A chameleon's eyeballs swivel on two different axes. I don't think anyone in this room can remotely imagine what the world looks like to a chameleon. So the nervous system and what we call external reality correspond to each other. But there are many kinds of nervous systems. And also nervous systems are actually created through culture, through history, through relationships, through interactions, through storytelling. Nervous systems are not fixed. We now know the new science of neuroplasticity. I just met a month ago, I met with Elizabeth Blackburn, who won the Nobel Prize for discovering telomerase many years ago. She just published a paper in the Academy of Sciences that within 4 months of meditative and contemplative practices, there are distinct changes in the so-called telomerase activity. Telomerase is an enzyme, and for an enzyme to go up 30%, there's got to be gene mediation. You've got to have transcription and translation. So the whole field of neuroplasticity, of genetic indeterminism, I don't know if you know, but within 4 months of lifestyle changes, including exercise, good sleep, good relationships, peace of mind, loving relationships, you can turn on 500 genes that actually influence things like autoimmune disease, inflammation, and so on. So except for the 5% of people who have really mutated genes, like say Alzheimer's specific or Huntington's chorea, most of our genes can be turned on and off. Right now, as I'm speaking to you, I'm influencing your neural networks, and I'm causing potentiation between neurons just through this interaction. And in order to do that, I have to go through your neuronal genes. I have to actually translate and transcribe certain genetic information. We're influencing each other's genes right now in our interaction. We are influencing our neural networks. There's a lot of plasticity. And what we call perceptual reality is an experience dependent on what the nervous system is doing at that moment. And our nervous system is very flexible. You know, we can change it through our interactions. In fact, we're doing it right now through Twitter and through Facebook and through social networks. We're seeing that our minds are entangled. Our minds are what we call embodied as well as relational processes that regulate the flow of energy and information, not only in our bodies, but in our interactions. So is there an ultimate reality? The answer for me is yes. That ultimate reality is the ground of existence, which many Eastern wisdom traditions have called consciousness. Now there's an argument. What is consciousness? You'll hear different opinions of what is consciousness. Here's my definition of consciousness. Consciousness is the ground of existence. And now, by the way, when I say existence, I'm not meaning anything esoteric. I'm meaning that which exists. Consciousness is the ground of existence that differentiates into everything we call reality. Our thoughts. Can you have thoughts without consciousness? Answer is no. Our cognition, our perception, our behavior, our speech, our biology, our social interactions, our personal relationships, our environment, our interaction with the forces of nature, these are differentiated aspects of this very fundamental reality which we cannot conceive of because it is the source of our conception, which we cannot perceive because it's the source of our perception. See, when we say is there an ultimate reality and will science ever be able to disclose it, I will say no. Science will never be able to disclose it because science is an activity in consciousness. Science, mathematics, these are activities in consciousness. Can you imagine a world outside of consciousness? You can't, because you have no way of stepping out of consciousness. Okay, so you're experiencing me in your consciousness. I'm experiencing you in my consciousness. I'm experiencing body in my consciousness. And even my scientific methodologies are in consciousness. Now, you know, a very elegant book that Mlodinow wrote with Stephen Hawking. It says the universe came out of nothing. At least I'm quoting accurately what I heard from Stephen. The universe came out of nothing, will continue to come out of nothing. And then he prefaced it, Stephen prefaced it anyway, because of a law called gravity. Okay? I am saying to you today that I hope by this evening, not with his thought experiment, but just through certain logic here, we will see the ultimate and climactic overthrow of the superstition of materialism. Because everything you call matter is non-material. Everything that you call physical is non-physical. If you go down to the most fundamental levels of nature, you go beyond, forget the observer effect, which is ridiculous, by the way he describes it, because according to him, the observers of the universe were created by the objects of the universe. Okay, so if you are there, an observer, which he says is a fiction, okay, but then he's using his mind to express his arguments.
My brain.
His brain, yeah. So we don't even have to address him. It's a brain. Okay? It's a brain. We are all zombies. We have no free will. We have no insight. We have no intuition. We have no creativity. We have no imagination. We have no choice. These are all my synaptic networks. You know, when in fact, even the synaptic networks are made out of atoms. The atoms are subatomic particles, and the particles are not things. The essential nature of the material world is that it's not material. The essential nature of the physical world is it's not physical. The essential stuff of the universe is non-stuff. Okay, now the question is, what is this non-stuff from where we all come? Is it just an empty void, or could it be the womb of creation? Does nature go to exactly the same place to create a galaxy of stars, a cluster of nebulas, a rainforest, a human body, or a thought? So the question is, let us figure out today what is the relationship between consciousness, energy, information, and matter. Could they all be the same thing in different disguises?
Our next speaker is our own Dean, Menas Kafatos, is the Fletcher Jones Endowed Professor of Computational Physics at Chapman University, and also Dean of the Schmidt College and Vice Chancellor for Special Projects. He's a physicist, but he has also written numerous books that address these issues of consciousness, in particular the conscious universe, the non-local universe, and principles of integrative science. Yeah.
Thank you, Daniel. I will take some pragmatic approach to the two questions, being a scientist. I heard so far that actually there's quite a bit of an agreement. I heard at least two sides agree that there's monism. I heard Mike say that he's a monist, and so did Deepak. So I would say also that I'm a monist. What I mean by that is that we as scientists could not do science, we could not practice science unless really we had a deep belief. It doesn't have to be belief that it's a dogmatic belief, but a sense, the kind of a sense that Einstein talked about, that there is something that can be studied with science, can be understood. And of course in physics we call them laws of nature. Today we know, though, that those laws of nature are not eternal. They certainly did not exist prior to the Big Bang, whatever that meant. And we have some other issues in physics today, such as the constants of nature, which can vary depending on what field theory you assume, or whether you espouse the great developments, or the recent developments of string theory. So we do practice science because we believe that we can get closer and closer and closer to it. However, to say that there is a reality, that it is out there, I would say that for what I've heard so far, we're probably, most of us are not going to subscribe to the view that there is no external reality. There is an external reality, but we are part of it. So the challenge for us as scientists today is how do we extend the wonderful bottom-up approach that we have, now working for about 400 years, that is so successful in terms of explaining phenomena according to prescriptions that we discover. We call them laws of physics, laws of biology, or perhaps laws of psychology. How do we go closer and closer to that? We, in an innate way, we assume that it is an ultimate reality. I don't believe that such a reality exists without us. Now, I'm not saying it does not exist without me particularly, or Deepak, or Mike Shermer, or Daniel Struber. No, that would be too soliptic. That's not what really we're talking about. It's not that the moon does not exist if Kafatos drops dead, or or the prodigy of Kafatos drop dead, or whatever. They all disappear. That's not the point. But we cannot unentangle the process of measurement from what we're trying to measure. I wish, folks, I wish really that there was an absolute external reality that was out there and me to discover it, or all of us to discover it. It doesn't seem to work that way. It just does not seem to work that way. We need to think of a science that allows us as observers to be an integral part of what we're trying to study. It's not easy because we as scientists have to separate our subjective experience, but understand also that ultimately the subjective experience may be driving the whole thing. So, in terms of practical steps, what several of us are discussing is I believe that ultimately we need to go deeper into the mathematical structure of the language of nature, which is mathematical. And in fact, Eugene Wigner, one of the great physicists of quantum revolution, talked about the unreasonable effectiveness of mathematics. So it has to be mathematics that goes beyond the dynamics that you have in general relativity, that you have in Newtonian physics, beyond the dynamics that you have even in string theory, to really address the qualitative aspects, the things that we know that are there but we cannot describe in mathematics. So we need to be working more and more into the mathematical language, and as we do that, what reality we're going to discover is more or less the reality we have been building on now for several hundred years, or in fact, if you like, 2,000 years, that we're getting closer and closer to something, but whether it is the complete picture, I don't believe that will happen anytime soon. Thank you.
Thank you, Menas. Now I think a change of pace. Our next speaker is actually Professor of Religious Studies. Carmichael Peters is the director of our University Honors Program and a professor of Religious Studies. Teaches courses in Buddhism, comparative religion, philosophical hermeneutics, philosophical political theology. So, Carmichael.
Thank you. I'm going to stick to my notes because there is a time limit that Daniele kept telling me about all week, and when I told him that I was going to run over, he suggested that I remove the articles and adjectives from my presentation, and that should help. So
and the vowels.
If this appears incomprehensible, it's because I've removed the articles and adjectives. The questions upon which this public conversation on the nature of reality focuses are, is there an ultimate reality, and if so, can it be accounted for by science? In other words, if ultimate reality exists, is it harmoniously related to the realities of our material universe? If the response to the first question is a categorical denial of the possibility of the existence of ultimate reality, then there seems little or no point to this evening's exercise, except probably a nice dinner later on. If, however, the existence of ultimate reality is an alive question, then its possible nature, as well as its possible relationship with our world, become existentially important. Given the limits of time permitted, I'm going to restrict my remarks to the consideration of two basic understandings of the relationship of ultimate reality with our world. One extrinsic, the other intrinsic. And in this way, I hope to address the second of our questions: can ultimate reality be accounted for by science? In the Spirit of Christianity, an article from his Frankfurt manuscripts, the German philosopher Hegel identifies an extrinsic interpretation of the experience of ultimate reality as the effect of and response to the God out there, the God outside and independent of the natural and historical worlds. Gregory Baum describes this God as the almighty supreme being in heaven, who, while having no communion with the cosmos and human history, graciously enters the lives of men and women to help them in their predicaments. Yet even then, this God remains the totally other, the divine stranger, the infinite object. It is difficult to imagine how a consistent development of this understanding would allow for the totally strange and separate God, the infinite and perfect object on high, to be experienced in such a way that the natural and historical orders participate necessarily in its reality. Even if some participation were conceivable, it would have to involve such a miraculous suspension of the laws of nature and the effects of history that there could only be radical discontinuity between the moment before and the moment after.
According to this interpretive understanding, an unavoidable and unbridgeable chasm divides ultimate reality from this world. And there appears to be just two ways to account for this chasm. Either it was there from the very beginning because of an original ontological dualism, or it is a subsequent development which resulted from some kind of primordial fall. In either case, ultimate reality is understood essentially as a meta-empirical reality. Can science, which deals primarily with the empirical realities of our material universe, account for ultimate reality understood as meta-empirical? In certain traditions, it has been claimed that solid knowledge of the meta-empirical cannot be gained through human sense perception or through the natural operations of human reason, but only through the miracle of revelation. If such traditional claims were granted, then the best that science could do with the meta-empirical would be to make inferences about it based upon empirical observations. Back in the day when such traditional claims held cultural and political sway, it was expected that if scientific inferences ever came into conflict with the imparted truths of revelation, scientists would give way to the authority of revelation. The failure to do so, the failure of scientists to genuflect before the authority of revelation by conforming their conclusions to its ordained truths, always came with serious consequences, such as the loss of freedom and for some even the loss of life. An alternative to this extrinsic understanding of the relationship of ultimate reality with our world has dawned for some, like Siddhartha Gautama and Albert Einstein, who have dared to contemplate the intricacies of human life and of our immense universe without dogmatically subscribing beforehand to any preordained conclusions. Such open-ended inquiry has led some to experience themselves as always already encompassed and permeated by that which is greater, by that which the human will cannot fully control, nor which the human intellect can fully grasp. Various interpretations of these kinds of experiences have led to a non-dualistic construal of ultimate reality as the fullness or depths of all things, such as they are. It is not at all difficult to see how a consistent development of such an understanding allows for no separation whatsoever between ultimate reality and this material universe. So where the earlier dualistic understanding assumes a chasm so radical that it posits only the possibility of an extrinsic and miraculous relationship between ultimate reality and our world, this non-dualistic understanding assumes an intimacy so radical that it posits only the possibility of an intrinsic and necessary relationship between them. Ultimate reality and this universe are experienced and understood as constituting an organic whole in which identity and difference harmoniously interplay. From the perspective of this non-dualistic understanding, it is hard to imagine how disciplined inquirers into the depths of human experience do not eventually awaken to the fact that reality as a whole always exhausts our understanding with remainder. Albert Einstein claims that to awaken to this fact is to awaken to the mysterious, which he calls the fairest thing we can experience. He goes on to say that the experience of the mysterious stands at the cradle of true art and true science, and that those who know it not no longer can experience wonder, no longer feel amazement, are as good as dead. For those who find themselves awed by the incredible beauty and coherence of reality as a whole, and at the same time find themselves intellectually humbled by its infinite intelligibility, for them, the line which marks where science ends and the arts and spirituality begin is not always all that clear. If this non-dualistic understanding has merit, then the question is not, can science account for ultimate reality, but rather, how can science avoid doing so? Let's see.
Thank you, Sir Michael. I think you would agree with me that we could have removed a few articles here and there. Our next speaker is Stuart Hameroff. Dr. Hameroff is an anesthesiologist and professor at the University of Arizona Medical Center in Tucson. He's known for his promotion of the scientific study of consciousness and his theories of the mechanism of consciousness. He's a co-author with Sir Roger Penrose of a theory that proposes that consciousness is the result of quantum computation mediated by quantum gravity effects. And he also directs the Center for Consciousness Studies at the University of Arizona.
Thank you. Hello, everybody. I take this question literally, and by that I mean I look at the fundamental level of the universe. If you go down in scale below the level of atoms, 25 orders of magnitude smaller, you get to the Planck scale, where there's information embedded. And at that level, there's something going on. Now, this dispute about whether there's an ultimate reality or not goes back to Bohr and Einstein. We've heard that Bohr was making quantum measurements, giving beautiful results, but it seemed to indicate that underneath those quantum measurements, reality was ambiguous or unclear or random or chaotic. And that was fine with Bohr. He was happy to make his measurements and do great things. Einstein wasn't pleased. He thought there was an underlying reality. He didn't know what it was, but he believed that underneath all those quantum measurements, something was there and was real and had information. Now, their modern counterparts of those two giants, in some sense, are Stephen Hawking and Roger Penrose. Hawking follows Bohr in that there's no...
It's okay.
Hawking and Leonard Mlodinow follow Bohr in that they're kind of ambiguous or vague about whether there's a reality. If there isn't, well, no big deal. And they take, of course, they apply string theory to the Planck scale where the strings are vibrating, but they don't say or can't account for what the strings are vibrating in. Now, Penrose, on the other hand, says that at this Planck scale, at this very fundamental level of the universe, is geometry. Quantum gravity, quantum geometry, spin networks, twistor theory, there's various approaches, but some kind of pattern or information that is encoded. And he goes on to say that encoded at that level are values, Platonic values, mathematical truth, perhaps even aesthetic and ethical values, and the precursors of consciousness, as well as perhaps the forces and constants that give rise to our universe. You know about the anthropic principle, the fact that the 25 or so constants and forces have to be precisely right to give life, starlight, life, and consciousness. And the view that you must take, that Hawking and Mlodinow, for example, take, is that there must be a gazillion universes, and we just happen to be in the one that has all the right constants, the Goldilocks principle, just right for life. And all those other ones, there's nobody conscious to worry about. Now, that necessitates a near infinite multitude of universes that are untestable and unknowable, a bit messy. Penrose says that this information, there's a cosmic blueprint, if you will, embedded at this fundamental level, and it includes the precursors of consciousness. This implies that consciousness didn't emerge happenstance during the course of evolution as kind of an after-the-fact epiphenomenon, And in fact, what Michael said about the mind and consciousness is completely wrong. We can explain what the brain does in terms of non-conscious processing, but when it comes to consciousness, there's really no good explanation. There's other things like backward time effects, free will, perfect synchrony across the brain, which seem to imply some kind of quantum mechanism. Now, Penrose and I have come up with a theory that makes a connection between quantum processes in the brain and this fundamental level of the universe to access these platonic values and proto-conscious entities built into the universe. And by the way, Penrose also has a new idea. It's in a book called Cycles of Time, that the universe was preceded by another universe, which was preceded perhaps by another one. And each cycle and Big Bang rebirth, these values may evolve and mutate. So we have serial evolving universes, reincarnation, if you will, of universes, as opposed to multiple universes. So I like the idea of serial rather than parallel universes. Now, our idea that the brain processes, quantum biology, connect to this fundamental level gets into Deepak's territory because it's very consistent with a lot of Vedic and Buddhist ideas that consciousness and spirituality, and at this fundamental level, there's non-locality, which means things repeat over space and time, and in some sense holographic at different scales, so that they can percolate up and be accessed and selected by conscious processes in the brain. And this is the fundamental idea of the theory that Penrose and I have come up with. So I don't believe that the mind is an emergent property or doesn't exist at all, as Michael was saying. And nor do I go quite as far as Deepak that consciousness is everything. But I think the stuff at the bottom, this fundamental space-time geometry, includes all this information, the blueprint of the universe, including the precursors of consciousness, so that our brains have evolved to the point where we can access and select and even be influenced and guided by information embedded in the fundamental level of the universe. And I think that's kind of a bridge, a potential bridge. And I should say Roger doesn't go into spiritual questions. He leaves that to me. And I have nothing to lose either, because I make my living passing gas as an anesthesiologist. But I seriously think that quantum processes in the brain connect us to this fundamental level, and that's a potential bridge between science and spirituality. Thank you.
And now to close this first round, we have another colleague from Chapman University, Professor Bill Wright. He's a professor of biology. He's a marine biologist and also a cellular neurophysiologist who investigates the neurophysiological basis of an evolution of learning and memory. He has included more than 50 undergraduate colleagues, as he called them, which I really like the terminology, in his research, and has been supported constantly by the National Science Foundation. Bill?
So the 8 panelists beforehand have sort of floated me off the floor, and I have to come back down again because my comments are much more anchored here. I'm not a philosopher, and I don't study history of science, and I'm definitely not a quantum mechanics student. But what I study instead, in this you say, why are you here? Well, the title of this conversation is the nature of reality, and I study nature, and that's what science does. And I think it's important that we, talk a little bit about science, since that's the actual question that we have here. And so I study science. I study a lot of things, but one thing I study is the evolution of learning and memory in sea slugs. And I do that because sea slugs have a really simple nervous system that's easily accessible by electrodes, and we can figure it out. And during the course of my studies, I found a sea slug that doesn't learn at all. It's just a completely non-learning species of sea slug. And I figured out what was missing in its brain to make it so it couldn't learn. It's just sort of like consciousness, I guess. But eventually, a student at Chapman approached me and said, well, how does the animal get along without being able to learn? And we hypothesized that learning was about avoiding predation in nature for these slugs, without very much evidence. But Kimmy took it one step farther and said, are you here, by the way, Kim? If you're here, raise your hand. No, okay. Well, maybe if these slugs aren't learning, and this learning is all about avoiding predation, maybe then they can compensate for not learning by having lots of nasty chemicals in their bodies. And slugs do this. Slugs put chemicals in their tissue so that they deter predators. And so it was a good hypothesis that there'd be a trade-off between the cognitive equipment and this chemical equipment. And I was very excited, and we went after it, and we actually had to spend some money to get a freeze dryer at Chapman, and to make these very special pellets that were quite precise and would powerfully test this hypothesis. So we tried first we put these pellets in front of crabs, and we let the crabs eat the pellets. When we made the pellets out of shrimp, which is very palatable, the crabs ate them just fine. And then when we made the pellets out of the smart slug, the one that learns, the crabs ate it about half as much, and there was no overlap at all. It was a very powerful method, and it was at this time that we started to be afraid. And you said, scientists being afraid? We were afraid that our hypothesis would be disproven. And that, I've learned actually over the years, is exactly what a scientist has to do. The scientist has to take their hypotheses and make them vulnerable. And so that's what we were doing here, and we didn't know what was going to happen. We knew we had a powerful test. And so then a few weeks later, the slug came in, and we had to do the experiment. And so we did the experiment. Remember, the idea was the smart slug eats this much. The crabs eat this much of the smart slug. The crabs eat this much of the shrimp. And we expected this guy to be even less palatable and the crabs wouldn't eat him virtually at all. What we found instead was that the crabs ate him like crazy, like they were candy. So crabs ate them like they were shrimp. So we were really chastened by this, because it took our hypothesis and not only disproved it, but we actually discovered the opposite of what we predicted. And we were, really crestfallen. We were pretty upset. And, we sort of gathered ourselves together and said, well, we did find something, right? Yeah, we did find something. So here we have this slug that doesn't think, and it doesn't put chemicals into its tissue. It doesn't even bother with predators. And so we presented this at a chemical ecology venue, and they loved it, right? They didn't know that our hypothesis had been disproven. They had no idea how crestfallen we were. So the take-home message from this parable, this is very different from the rest of the people in the panel, is that there's a really important thing about science that I think everyone in the audience should keep track of, and I hope that the panel comes back to a little bit, is what can I do to test my hypothesis? Making a test of a hypothesis is, in a way, a more noble enterprise than the hypothesis itself.
Bravo.
So I guess that's the challenge to the panel for the next round, if you would.
All right.
Well, thank you to the panel. Now we are ready for round two. Now almost everybody went above their 5 minutes. They promised me they were going to be shorter in the second round.
Can I just, being empirical, I've observed the amount of time we took. And projecting, I don't know how long we're supposed to go, but...
we could try to do it 3 minutes each, and this time
maybe we should take
really hold
questions.
you to that.
Oh,
how
Yeah,
about that?
but I kept them my 5 minutes.
Jim, 3 minutes.
3 minutes, I'm on. Yeah, this sort of reminds me, listening to everybody, of that great painting by Raphael where he's got the older Plato, the idealist, pointing to the heavens. He's got the younger Aristotle, the realist, pointing to the earth. And that kind of reminds me of this panel, is that we're split between people pointing to the heavens and pointing to the earth. And from my standpoint, as a research institute that is looking for practical solutions, which gets back to what Bill was saying, which is testing hypothesis, making products that actually benefit people and are useful, what we have to do is create a big enough tent. It creates not only Deepak's mythic spiritual imagination, but also Mike's reductionist science. In a way that, because if you think about science, every advancement in science came from a new audacity of imagination. Einstein said it best. He said, we know 1/1000th of 1% of what nature's revealed to us. So keeping that humility in mind, taking a look at our particular spot in the holographic universe and how we're viewing science and reality in that moment. My view, depending on where I am in that, could be entirely different than Henry's view, and he might think I'm crazy. But in reality, it's the same holographic universe that we're talking about. So the mind itself, if it has any humility, has to realize it can't perceive reality. Because if it perceived real reality, it would dissolve itself, knowing it's illusionary. So what I'd like to propose is we have a little bit of sympathy for the human process. We forgive each other our imperfect view of reality and recognize it's part of the human process. And that part of the human process is, as we go along, we change our view, we evolve, and ultimately we get to the point where perhaps we don't need a method, and perhaps we don't need words. It is, in fact, beingness that is reality. And so what I'd like to, from our standpoint, from a research institute, is our goal is to investigate reality and consciousness in a way that helps people get to the point we don't have to do that anymore. So with that, I'll turn to Henry.
Thank you. And that was 3 minutes. Great job.
Thank you.
Henry, 3 minutes.
Well, I first want to say a word about this idea that that's often stated that, well, quantum mechanics is a mystery and consciousness is a mystery. Therefore, I mean, like somebody who doesn't understand consciousness and doesn't understand quantum mechanics says, well, therefore they must be related. And you hear that often, but I don't think it's quite accurate because this association of consciousness with quantum theory was really an essential part of the development of quantum theory itself. I mean, these issues are brought together by the quantum theorists, and there are thousands of papers written by very serious quantum physicists, and they are putting these two things together. So it's not just the two things are mysteries, therefore they're related. The quantum theorists themselves are putting these two things together and trying to figure out how they mesh. Now the second thing is, we heard a talk down there about backward in time effect. And by the way, most of the panelists probably know there's been a very recent experiment by a Cornell physicist, BEM, which seems to indicate that there is some sort of mysterious backward in time effect. Maybe it'll go away, it's a new experiment, but an essential part of quantum theory as it's understood is something called Wheeler's delayed choice experiment, and I can't describe it in 3 minutes, but the main point is it's what you choose now determines what happened much earlier. It can, and these experiments have actually been done. What you choose to do now determines what happened in the past, and in fact, in Leonard's book with Hawking, they say it because of this effect, the choice, the observer's choice, by his choice of what to do now, creates the history, not the history creates the observer. And so this is a very funny part of quantum mechanics, and the point is quantum theory is a mystery, and but the observer seems to be, as far as we can understand, an essential part of it. So I don't think you can wave this thing off and just say they're both mysteries, therefore somehow they're connected.
Thank you. Glenn?
Wow.
I really lost 10 seconds.
Feel like, I know, that's all right. You know how you clutch up sometimes when you go to a buffet and there's so much to eat and you don't know what to go first. And you have one little plate this big. How am I going to even do that? So I just want to say one thing. Since we had such a wonderful story about hypotheses and testing, you know, that looking to see if you're right is the important thing. I'll just add as another facet of that precision and being not vague, but really precise mathematically, phrasing your questions, which we're not going to do on the stage here, but in general is very important in science. And if you relax that requirement and you allow wombs of creation and Platonic values in the Planck time, space-time, then I think that it's very hard to come to any conclusion about what they mean or you know what value those ideas have. I think in the case of Deepak's womb, you know, it's sure in physics we have the same thing. You know, the vacuum state, and so but what we do is we take it and it's a mathematical. We define it mathematically and put it into a theory and derive consequences from it, and so it has a certain very specific meaning that you have to study a lot to understand exactly what it means. But it is defined very precisely, and I guess I'll just issue a warning that we should require that of the concepts being discussed.
Thank you.
Yeah.
Michael?
Okay, Deepak, when you use phrases like womb of creation, this is what I'm talking about with the Dr. Woo-woo stuff. It's not precise, and I have a feeling you don't mean it metaphorically, poetically, etc., which would be fine, but I have a feeling that's not how you're using it. So that's a problem. Consciousness is in the same category. It's not clearly defined. So you said at the base of reality is consciousness. And then you ventured a definition of consciousness. It's the ground of existence. At the base of reality is the ground of existence. Reality is existence. Existence is existence. You've explained nothing. That's tautological. This is like saying gravity is the tendency for objects to attract to one another. Why do objects attract to one another? Because of gravity. See, it doesn't explain anything. See, we have to have operationally defined, testable hypotheses about these things, like let's take the sea slug. Yay, finally, okay, something to work with. Why don't you conscious guys talk about the sea slug in quantum mechanics? Why don't we see any papers on consciousness in the sea slug in quantum mechanics? Because it isn't us, right? It's not our you know, evolved superbrain. And so that's what bothers me about that. Now, Stuart, you still, what I would like to know, I'd like you to answer this question. Where is Aunt Millie's mind when her brain is disintegrating in Alzheimer's or senility? Where did it go? If it still exists somewhere, where is it, and can we test it? Because that would be indistinguishable from it not existing at all if you just say we can't access it.
You want to know now, or you
want to? Well, you can do it. You can do it when you get there. And by the way, I think you're not a holist.
She's right there.
Aunt Millie's there. I think you're not a holist. You guys are not holists. You're ultimately reductionists. 25 orders of magnitude smaller, all the way down to the Planck scale. That's reductionism. You don't have to go that far. You can start at the neural level. That's the atom of the thought. Okay, so one last thing. This backward time thing, I just wrote an analysis of this for Scientific American. Okay, this is a deeply flawed, in my opinion, experiment. So here it is. College students are looking at a computer screen and they have to guess whether the image is going to appear on the left side of the screen or the right side of the screen. There's a little curtain there. And behind one of them are neutral images, behind the other are erotic images. College students thinking about erotica, okay. And for some reason, they were able to pick the erotica ones more than the neutral ones. And Stephen Colbert called this extrasensory pornception, or time-traveling pornography. Anyway, so
only if they saw them later at a later time.
Yeah, that's right. Yeah. So, okay. Anyway, so it's being published. Okay, whatever. I mean, something like more than 50% of peer-reviewed papers turn out not to be true. I promise you, this will be one of them. It doesn't match the way we know that the world works. Anyway, so I just think the key word here on quantum consciousness is baloney.
Thank you. Deepak, just 3 minutes.
3 minutes. So, Michael, whenever he doesn't understand anything, he uses words like baloney, woo, etc. You have a gall being in the presence of physicists who were colleagues of Heisenberg and Wolfgang Pauli to say quantum consciousness baloney, observer baloney. You have real
That's just an argument from
impertinence.
authority.
Okay?
That's authority.
Now, I'm just going to do an experiment with you right now. Can you imagine a sunset right now? Do you see it? Is there a picture? Where is it? If I looked inside your brain, I'd see electromagnetic. My turn. If I looked inside your brain, I'll see neurotransmitters and synaptic firings. You're seeing a picture. Where is that picture? That's called the hard question right now. Nobody knows. Nobody has a theory of it. Okay, when you see this bottle, what's coming from here is a colorless photon. It's sending electrical firings to your brain, and there are synaptic firings and chemicals. Nobody has a picture, nobody has the biggest idea how you see this bottle. It's called the hard question. And it is a well-known dilemma because there's no theory. Your brain, which is inside your head, has no experience of the external world. The brain cells respond to pH, electrolytes, hormones, body temperature, and ultimately electrical ionic shifts. How does it create the experience of the external world? There's no theory. The scientists say we'll have a theory, it's a promissory note, and in this economic environment, we're not accepting promissory notes. Okay? So the question is, we have no idea how the Big Bang occurred. We have no idea what happened in the first 10 to the power of minus 43 seconds, not even the theory. We have no idea why the constants are as they are, unless we postulate 10 to the power of 500 universes. We have no idea how inanimate matter became animate. We have no idea how the human nervous system, which is an activity of the universe, is self-referential. We have too many questions that we don't know. So is there an ultimate reality? If there is, science is not going to be able to answer it because science is also an expression of that ultimate reality. Your nervous system is not a material object. Your nervous system is an activity of the universe. Okay? And there are people in this audience who can talk about time-symmetric mechanics, how the information in the future leaks into the present, resolves indeterminacies, and they are very well published. Forget about peer-reviewed journals. They are very well published with very high credentials. There's a lot we don't know about backward time, delayed choice, time-symmetric. There's a lot we don't know about non-locality, which is a given now in physics. How does a realm of existence exist where everything is correlated? How does your body function as an integrated whole? You know, how does a human body think, thoughts, play a piano, kill germs, remove toxins, and make a baby all at the same time, while tracking the movement of stars and planets because your biological rhythms are tied to the symphony of the universe? We have to go beyond this mechanistic, reductionist, obsolete science, which is frozen in an obsolete worldview. That obsolete worldview looks only at the universe out there, at the objects, totally ignoring the observer, which is a myth. So I'm not arguing with Michael, I'm arguing with his synaptic networks. Okay?
Thank you. I come from a Greek background, and we have a religion in Greece that we call Orthodox Church. I have always been against Orthodoxy, not against the Orthodox Church, but against Orthodoxy. We have to be very careful as scientists not to be dismissive of what we don't understand, not to laugh at something that we don't capture with our limited imagination or limited understanding, but really to look forward, because in fact science has progressed all the time by these leaps of understanding that a few people, including Albert Einstein, you know, when he wrote his theory of relativity, special theory of relativity, everybody was laughing, you know, they were dismissing him. And it was not in fact until Sir Arthur Eddington went and observed the starlight, the deflection of starlight during a total solar eclipse in 1915, that Einstein became instantly famous, and people paid attention because of the effort that Eddington put into this thing. So, because we don't understand something today, it doesn't mean that that's it. The game is over. I want also to give you another historical example. It was Kelvin, Lord Kelvin, who at the more or less the turn of the 19th century predicted that the end of physics was at hand. There were only really two little clouds that hung in the horizon, and one was namely the Lorentz, what eventually became the Lorentz transformation, special relativity, namely the Michelson-Morley experiment. I won't go into that too much. And the other one was the behavior of photons in so-called black body radiation. Well, the first one gave the theory of relativity, and the second one gave quantum theory within a few years after Lord Kelvin had spoken those words. So science is against orthodoxy. We as scientists have to be very careful not to be dismissive just because we don't capture with our current understanding. And the last point I want to say in terms of what Bill was saying a while ago, of course, yes, we always have to test our hypothesis. Einstein, again, I'll use the example of Einstein. When they ask him, well, why do you come with the tensor idea of the general theory of relativity? There was absolutely no laboratory experiment at the time that could have predicted that. And he said, because it is right. And said, how do you know it's right? Because he said, if God existed, he would have to make it that way. So there was his deep mathematical understanding, which eventually gave birth to the laboratory experiments, the astronomical observations. He was so sure about it, and he was right. So we have to be very careful not to be dismissive of the other side, so to speak, just because we don't understand it currently.
Michael?
If I could say something about orthodoxy, I would agree that we have to be careful in every field about orthodoxy, but I would use the word dogmatism rather than orthodoxy. Sure. And if when I was reading Einstein and he talked about the experience of the mysterious, he wasn't talking about some parallel universe with, you know, some mystical thing, but I think he was pointing to a datum of human experience, that our universe, we experience it as a mystery, and he didn't mean by that which cannot be understood, but rather that which is infinitely intelligible. And I think that understanding of mystery is important for intellectual humility and an undermining of dogmatism.
Thank you.
Thank you. So let me respond to a couple of things Michael said. Consciousness is vague, not to me. Consciousness is what goes away with anesthesia and comes back when I turn off the vaporizer. And while my patients are under anesthesia, their brains are quite active. We do evoke potentials. They have slower EEG. They process information. We do that for spine surgery to measure the integrity of the spinal cord. Their brains are active. All that's missing is consciousness. And the anesthetic gases act strictly by quantum London forces. They don't form chemical or ionic bonds. So they erase consciousness. Everything continues. He called quantum consciousness baloney. In an article a few years ago in Scientific American, he criticized me and Roger, and he cited the fact that quantum biology is impossible by a guy named Victor Stenger, who had an idea that mass times velocity times distance can't exceed the Planck scale. Well, that's been proven wrong 1,000-fold by fullerene molecules, porphyrins in superposition by Zeilinger, and the quantum tuning fork, actually nanoscale, but still zillions of atoms. So the argument that he used in that piece, which he referred to quantum quackery, which I resent as a physician, by the way. So I think you're full of baloney. And finally, experiments in Japan by Anirban Banyapati have now shown quantum states in microtubules lasting at least 0.1 millisecond over 21 microns, and for 0.1 milliseconds. So it shows that at least mesoscopic microtubules, which is where we think consciousness is residing, can be quantum. Now, reductionism, going to the Planck scale is reductionist, yes, but when you get to the quantum, you get non-locality. So everything changes. So you call it reductionist, but it's not materialist. Backward time, Daryl Bem's paper was one in the most recent, a long series going back to Ben Libet showing backward time effects in the brain. Bierman and Radin showed it in emotional experiments. at the upcoming Tour de Science of Consciousness in Stockholm next month, in early May, there'll be a number of papers from monkey talks, monkey amygdala with backward time, humans with implanted electrodes showing backward time, looking at faces. It's a fact. It's hard to, in fact, conventional mainstream neuroscientists find it in their data, but they ignore it. And you say, yeah, we saw that, but we can't talk about that. So it's there, and if you want to be scientific about it, you have to address that. Aunt Millie. Okay. So I've been asked this a number of times, near-death experience, out-of-body experiences, and most recently a TV show about reincarnation. And they had this kid who had memories of a World War II fighter pilot who died, and there was no way the kid could know these details. And they asked me, well, how do you explain that, wise guy? And I said, well, I don't know for sure, and I can't validate this is true, but there certainly are a lot of anecdotal stories about this that seem hard to explain. So I said, in our view, that consciousness is happening in the brain, in the microtubules, in the neurons, but going down to the Planck scale geometry. Still there? Going down to the Planck scale geometry between the ears. Now, when the blood stops flowing, the heart stops, the brain becomes acidotic, ischemic, there's no blood flow. The quantum information, the microtubules stop being coherent, but the quantum information in the Planck scale isn't lost, but can delocalize or dissipate to the universe at large and remain in the Planck scale non-locally. So it's conceivable. I'm not saying that I don't claim evidence, but I'm claiming a scientific plausibility for consciousness out of the body after death that could even, in the Planck scale, non-locally distributed, but remaining as a soul, if you will, a quantum soul, by entanglement, which could, in principle, go back inside another zygote or embryo, and the microtubules inside another zygote or embryo. So I think that's scientifically possible.
Stuart, time.
That's it?
Yep, that's it. Thank you.
Okay, I guess I'm going to close this off. I think that I want to come back to testing hypotheses, and Menas, you said, of course we test hypotheses. But I do think that the general public at large is not so aware of the importance of testing hypotheses. How many of you have heard of Einstein inventing general relativity? Raise your hand. Okay, so now how many of those that raised your hand know what the empirical test of that general relativity is? A much smaller percentage. Most of the people here do, but it was a watershed moment when they saw a star behind a solar eclipse, and it brought general relativity to the citizens. It brought us humility. So the testing the hypotheses brings science humility. Without it, you just have another arrogant science.
Okay, while they bring me some of the questions, I don't know if they're coming from there, I'd like to ask you to please thank our panelists, especially for their being so good the second time. Thank you. We actually recuperated quite a bit of time, so we have about 20 minutes to go with a few questions. Okay, this is a question for Deepak. What happens with psychic sleep? Body rests with the heart always beating, always, or your mind goes to sleep?
I don't understand the question, but I can say that your mind, your emotions, your breath, your autonomic nervous system, your limbic system, your brain and your body are an integrated process. And one is not separate from the other. If I give you information right now that you have a terminal disease, that will affect every biological response in your body instantly. So you metabolize information into biological response. If I tell you, on the other hand, that you won the lottery, or that this lovely girl is in love with you, you might have a different biological response. So we cannot separate mind from body or consciousness. Their mind, body, and consciousness are an integral whole, period.
This is an interesting question from one of our MBA students. How does language affect what we understand, and how do we define the nature of reality? It doesn't say who should be answering. Anybody wants to pick this up?
Yeah, I could pick it up.
Oh, sure.
It was actually Niels Bohr who wrote extensively about the importance of language and brought out the problems with understanding quantum theory that really had to do with the language that we are used to everyday experience. And that language does not translate into quantum phenomena. So we have to think of the importance of language, and maybe a dialogue with linguists and physicists is very, very important at this point.
But you see, this is an example here where Stuart said he was going to define consciousness, so language matters. But he didn't. He just said it's what goes away when I give him anesthesia. That's not a definition of consciousness.
I'll do it.
Just tell us what you think it is.
It's a self-collapse of the wave function. Objective reduction is defined by Penrose. Superposition reaches a threshold, has a moment of consciousness. That happens roughly 40 times a second in our brains. It connects brain processes, including the cognitive information, to the fundamental level of the universe where the proto-conscious qualia are, and that's what consciousness is.
But he doesn't get that.
Stuart, you know, I have to say, to a physicist, the physics that you spoke there sounds like Greek spoken backwards.
Yeah, because
it doesn't
you're not
mean
a
anything.
biologist.
What?
He's a physicist.
But I mean, the quantum, the collapse of the wave function. What are you talking about?
Well, okay, let me answer.
Okay, guys.
This is where the action is.
You're using the physics terminology, but
it's not the observer effect. Okay, you don't need. Bohr
what are you talking? Let's just take one thing.
outside-
I understand the collapse of the wave function. Can you tell me what you're talking about?
It's a self-collapse of the wave function.
What does that mean?
That means.
What is
Pardon me?
what?
What's the second sleep?
I don't know. Second sleep. I don't know what you're referring. Can I
So, yeah.
answer his question? Penrose. Okay. Penrose objective reduction, which he postulated in '89 as the mechanism for consciousness, means when you have a superposition that avoids decoherence by E equals h over t. E equals is the superposition separation and gravitational self-energy. H is Planck's constant over 2 pi. T is the time at which we'll reach self-collapse, this objective reduction. When that happens, it's a moment of consciousness. Something like a Whitehead occasion of experience, like a Buddhist moment of awareness. It's a moment of consciousness. It happens roughly 40 times a second at gamma synchrony rates, or higher, faster if you're in an excited state. And that's how we have 40 or more moments of consciousness per second.
What is a wave function, Stuart?
Okay.
It's a super. I think it's real. I think it's real.
I think these are just terms being strung together, with some from biology, some from physics, and they don't have any meaning.
This is the moment for the audience. If we can start having
Can I ask the audience?
Fair enough.
There is a question from the audience.
Can I text one to somebody?
Hopefully-
and you can bring it up here?
Hopefully not from one of our students. The question is, altered states due to chemical drugs. Is that a separate reality or is part of the same reality? How do they affect our thinking?
Can I answer that?
No, let's see if anybody else that wants
He's
to
an
pick.
anesthesiologist.
All right, anesthesiologist. Good point.
Anesthetics reduce the quantum mobility in these hydrophobic pockets inside proteins. Psychedelic drugs was shown in the 1970s by Kang and Green and Saul Snyder and others in these assays, that when they mix them, put them with the receptors, the more potent the psychedelic compound was, the more it promoted, the more electron resonance energy it donated to the receptor. Which means, in my view, that these psychedelic compounds push the system more into the quantum state, more into
What does that mean?
that means deep interconnectedness, hidden meanings, more quantum non-locality. And I think enlightened states through meditation or drugs, we go deeper, faster rates of consciousness, maybe from 40 to hundreds moments per second. Greater intensity, it's like shifting on the electromagnetic spectrum from infrared to ultraviolet, or even higher. So we have higher intensity, more conscious moments, which means the perceived world slows down, and we're more in touch with the underlying proto-consciousness in the universe.
Okay, comment from Deepak, and then I have another question from Bob.
Just one comment. Like right now, you're all listening to me. Right now, just turn your attention to who's listening. Okay, so be aware of who's listening.
Okay.
That's consciousness, okay? It's not a thought. which might be, I wish I'd gone to the bathroom before I went to this lecture. Yeah, a thought is a fluctuation in that awareness. That's experiential. Now, one more thing, there are physicists here, published physicists here, who can give you information on non-locality, which is a term that these guys totally avoid because it's the white elephant in the room. What is non-locality? What is that domain outside of space and time, which is where everything is correlated? What is non-locality? Jeff, you're a physicist here.
We're gonna get somebody from the audience now. That's audience action. Jeff, do you want to come up? Jeff Talexon is a professor of physics here at Chapman University, and he is often lectured about the issue of non-locality. So since that's something that's been mentioned, and it's probably not a household term, we'll ask you to say a couple of words about non-locality.
Okay, so I have, what, 20 minutes?
No, you have to stick with it. 4 minutes. 4 minutes for you.
time while you're at it.
All right, well, nature of reality. Well, in short, I don't know. I don't know. But the ultimate nature. Can you hear me okay? No? Is it better? Okay? Okay. Ultimate nature of reality, of course.
Non-locality.
Non-locality. Okay. So this is the discovery that comes out of orthodox quantum mechanics. What is quantum mechanics? It's a theory. It's about 80 years old. It's regarded as the most successful theory in the whole history of human civilization. And non-locality, Henry, I think you've characterized it as one of the most profound discoveries of science. It's really dramatic. I don't really know how to express it to you more profoundly. I mean,
You're defining it like Stuart defines consciousness.
Okay, you want to know what it is? We have 2 minutes left. It's
Don't keep them in this suspense. Explain what. Just tell us.
Okay, everybody go to the bathroom now and come back. There are 2 aspects to it. There's an aspect that was really started by a question that Einstein posed. He was very worried about one of these profound changes about the nature of reality that came about through quantum mechanics. This seemed to be the throwing out of something called determinism. And before that, from our Newton, Sir Isaac Newton, it looked like we could understand, if we understood the state of the universe at one time, we understood how things evolved, we could understand everything. Everything could, in principle, be understood about the nature of the universe. So this business called non-locality suggests that there are connections across vast distances in space and time which you can never put together according to the classical way of thinking about it. Things seem to be connected in very strange ways. Now there's a real restriction to how this happens, because you can't use this to send signals faster than light, the thing that Einstein said there's a maximum speed limit, speed of light. So don't use it for that. Turns out it's an incredibly useful thing in physics. All kinds of useful discoveries come out of it, all kinds of useful new technologies, new understandings, and so on and so forth. So this is really, I guess my point is that there's just tremendous number of very, very exciting new discoveries coming out all the time in science. And it's kind of an indication that maybe we don't have a deep intuition. We don't really even know where to begin to answer that question. But I can tell you that there are, in my opinion, 3 pillars as to how, where some of the most exciting research is happening. One is the business of non-locality. And this shows up not only in the way things are connected across vast distances in space and time, but in also the way things interact. This is incredibly dramatic. I can't emphasize it enough. This is an amazing aspect of the grandeur of the universe. And the other aspect is very strange relationships in time. The whole business of the nature of the flow of time, which seems to be, very fundamental in our experience. This is, there's a lot of new research on this, and there's some very exciting new discoveries in this aspect.
Thank you.
There is going to be a quiz at the exit about non-locality, so you better make sure you understand.
Can I take just give me 2 minutes.
There is a question for you,
on
but
non-locality.
okay, non-locality from Leonard Mlodinow.
Just very simply, okay, in normal experience, if two things are to affect each other, they have to have contact. So if Michael's going to throw you off the roof, he has to be there with you and throw you off the roof, or Deepak. And so they have to have contact in space. That's called locality. Something that affects something else has to be local. Even if there's a force between two objects, there's a force field that makes it happen. It doesn't just happen across space. So in quantum theory, there's an effect where something can be kind of in two places at one time in a way, which I won't get into because I don't want to go over the 2 minutes. But as a result, when you do something at one side, to one of the locations, the other location, which is not in contact, which could be at the other side of the universe, light years away, is affected by what you did here. That's non-locality. Something that is not locally, not in the same place, doesn't touch it, doesn't communicate with it, can affect something that happens elsewhere. Okay, so that's just in a basic level what non-locality means. But it's important to know that it's a subtle thing, and you can't use it, say, to communicate faster than light or anything like that. But I won't go into the details, but in quantum theory, that is what non-locality is.
And that's
Can I have 30 seconds?
I have a follow-up question actually for Len that comes from the audience.
Can I have 30 seconds just to say?
Should we give you 30 seconds?
Yeah, please. The way quantum theory works, you have questions that are posed by experimenters or observers, and nature gives an answer. In this situation, you have questions being posed by observers in various parts of the universe, and what happens is that in order to give the answer here, you cannot assume that it is unaware of all the questions that are asked over here.
Okay, so the question for you is, I don't understand exactly what it means, but do you envision, that's why it's for you, do you envision a time when humans can perceive directly any of the 11 dimensions of M theory?
Oh, do I? Well, first of all, let me say that I don't make Lord Kelvin's mistake and make predictions about what the future of science is. And I think that's a mistake that's been made, actually not just by him, but by many people many famous people through history. In fact, a famous scientist, I forget who it was, about 2 years before the Wright brothers said we'll never have airplanes. That's another good one. So I won't predict, but current M theory, as it currently is, and it is a work in progress, and we know very little about it. If it's correct, then these dimensions seem to be too small to ever be observed.
So is that a testable hypothesis?
Yes, it is a testable hypothesis.
How's it testable if you can't?
I'll tell you how. So a theory must be testable to be valid in science, and it must make predictions that are falsifiable, like the sea slugs. But a theory can also have elements. Not every element of the theory needs to be testable. The theory needs to have testable predictions, but it can also have elements in it that aren't testable, that's perfectly valid, as long as there's a way to falsify the theory. You don't have to be able to test every element. And then sometime you might be able to come up with a test of those elements if you don't know how to test them now. But all that we demand of the theory is that it makes some testable predictions. And the more testable predictions that survive the experiment, the more faith we have in the theory.
10 to the power of 500 universe is testable?
The theory. First of all, let me say again, M theory is still being worked out. Okay, but the theory, in theory, the theory is testable. Okay, people will not stay with the theory if they think it's not testable. So now, whether or not the other universes are, according to the theory, and causally disconnected from ours, so we can't go there, we can't observe them, and in a sense it's just philosophical speculation to talk about them. Well, but as I said, for a theory to be accepted in science, all the predictions, all the elements of the theory don't have to themselves be testable. It just has to make a number.
That M theory is totally inelegant as far as science is
concerned. Well, that's your mathematical assessment, and other people who've studied mathematics have other feelings about
Is it falsifiable?
Okay, let me close. We have one more question for 4 people. So I think that I read this question. The 4 people are Stuart, Michael, Deepak, and Henry. So, and the question is, Werner Heisenberg was quoted as saying, what we see is not nature around us, but nature exposed to our method of questioning. Can you tell us whether you agree, disagree, and explain why? Maybe we start with Stuart.
Yeah, Heisenberg was stopped by a cop for speeding, and he said, "Do you know how fast you're going?" And Heisenberg said, "No, but I know exactly where I am." I'm not sure, actually. I didn't quite follow the question, but let me just make the point that that you don't need a conscious observer outside science, that, as Bohr and Wigner and a lot of the Copenhagen. In our view, consciousness is intrinsic in the universe. It's on the edge between the quantum and classical worlds. It's related to something that's been there all along. We don't want to put it outside science. I'll just leave it at that.
Deepak, do you want me to read again? Or?
No, I get the question. I'm very familiar with the quote, and Heisenberg is exactly correct. We do not see nature as it is, but we see nature as it is exposed to our method of questioning. The scientific method of questioning is a particular method which is based on a fundamental subject-object split. So, that I am the subject, and there's the object, and nature is the object. But my question is, how do you get outside of nature to observe? How do you measure the universe from inside the universe, because you're as much an activity of the universe? So science is a method for exploring a particular map of the truth, but it's not a method for exploring ultimate reality.
Thank you. Michael?
Yeah, this quote is in Deepak's paper, co-authored with Professor Kafatos, that he asked me to read and comment on tonight. And I wrote, by the way, this paper is called How Consciousness Becomes the Physical Universe. It's the second word in the title, and they don't even define it. We will sidestep any precise definition of consciousness, limiting ourselves for now to willful actions on the part of the observer. So what can it possibly mean for the universe to be conscious? It's willful actions, it's an observer. Anyway, this is the problem with this, that without precise, operationally defined terms, we can't really sink our teeth into it experimentally and say whether there's any sense made in this. So with the Heisenberg quote, I just wrote, this would imply that anyone's method of questioning is just as valid as anyone else's. The astrologers' questions about the universe are just as valid as the astronomers. Well, maybe in some philosophical drinking club, but if you want to get a spacecraft to Mars, you use astronomy. The questions those guys ask are way better than the astrologers by any objective standard.
Henry, you care to comment on this?
Yeah. So I've already, I'm just reiterating what I already said, really, but let me say it again. The way that quantum theory at least works, and I think Heisenberg was referring now to quantum theory, specifically, although viewed from a general philosophical perspective. The way it works is that you actually have three processes going on. You have the physical process, which is the generalization of the classical mechanical deterministic processes described in terms of mathematical and physical variables. And then you have to, but that generates this gigantic world of possibilities which doesn't agree with experiment. Now, the way quantum theory works, at least, and this ties exactly into quantum theory, is that in order to eventually get your theory to agree with experience, you have to have what turns out to be two more stages that bring you up to agreement with experience. The first of these stages is the observer has to pose a specific question. And in fact, in the book of Leonard and Hawking's, they talk about this top-down approach. In order to make sense of this theory, this M-function theory, you basically say, well, some sort of experience happens, and the question is, well, what causes that particular experience to come into being? And the way that quantum theory deals with that question is to say that in order, and this is at least a procedure, and the procedure that's taught in your quantum mechanics courses, and is that the experimenter has to pose a particular question. This is we're talking about science, we're talking about physics, we're talking about how quantum physics is taught. The observer, experimenter has to ask a question of nature, and then nature responds in this non-global way. And so that's what he was referring to. In order to to make an understanding of nature as it was revealed to us by the experiments that overthrew classical mechanics and move on to a new understanding of nature. The understanding provided by quantum mechanics did involve these three stages, and one stage was somehow a question. And the point is, this question was not determined in any way by the underlying deterministic laws of motion. The Schrödinger equation, the deterministic law of motion, does not determine the question. And so that's the essential core of this whole discussion. You have this question that seems to be needed in order to make quantum mechanics work, and you don't have a real understanding of where it comes from. And so the quote says, well, it's nature exposed to our questioning of it.
Thank you. Well, ladies and gentlemen, thank you very much. Thank you again our panel.
Let's thank you, Scott.
And thank you to all of us, all the staff that has helped with this humongous event. Thank you.
Yep. Thank you.